Find the best country to build a power plant. In this problem, a power plant can be built in one of 6 countries: Italy, Belgium, Germany, the UK, Portugal, or France. The different countries are to be compared using 6 criteria, 3 of which include the capital expense of constructing the plant, the number of workers needed to run the plant, and the environmental impacts caused by pollution. The problem states to use the Prométhée 1 and 2 outranking methods, which stand for Preference Ranking Organization Method for Enrichment Evaluation. The 6 criteria used to decide in which country a plant should be built include the number of workers needed to run the plant, which should be minimized, the quantity of power produced, which should be maximized, the cost of construction, which should be minimized, the cost of annual maintenance, which should be minimized, the impact to the environment, which should be minimized, and the security at the power plant site, which should be maximized. The units for the 6 criteria are the number of workers for workers, megawatts for the units of power, and $1 million for the cost of construction and annual maintenance. The environmental impact and degree of security criteria are harder to measure and less objective in nature than the number of workers, the power production, or the costs. Therefore, the environmental impact and security are simply scored on a level from 1 to 10, where 1 is the least impact on the environment and least secure location, and 10 is the most impact on the environment and most secure location. Prométhée uses weights to identify which criteria are most important to the decision maker. In this method, the weights sum to 1, and for this problem, arbitrary weights are assigned to each criterion. A table of data is provided showing the value of each criterion for each country. Keeping in mind, the quantities in this table are in the units previously mentioned for each criterion. The next step in Prométhée is to develop fuzzy dominance relations for each criterion. For example, if we consider the first criterion, the number of workers at the plant, we want to quantify the degree of truth the number of workers working at a plant in one country is preferred over the number of workers working at a plant in another country. For example, the first criterion is to minimize the number of workers required to work at the plant. If we compare the 80 workers required to work at a plant built in Italy against the 65 workers required to work at a plant built in Belgium, there is zero truth to the proposition that the Italian plant is preferred over the Belgian plant for this criterion, because the deviation of the Italian plant over the Belgian plant is negative, which corresponds to a 0 degree of truth. The degree of truth the Belgian plant is preferred over the Italian plant for this criterion depends on the preference relationship. This is an example of a linear preference relationship, but there are others which we'll return to later. Including the other 5 criteria and assigning Italy the letter A and Belgium the letter B, pi AB equals the sum of the products of the weights of each criterion and the degree of truth a power plant is preferred in country A over country B. As an example, we'll assume the following degrees of truth and multiply them by the actual weights, we previously assigned to each criterion, which would make pi AB equal to 0.295. After the plant in Italy is compared against the plant in Belgium, it is next compared against the plant in Germany, then against the plant in the UK, then Portugal, then France. After these comparisons are made, we can construct a table of pi values for degrees of truth the plant in Italy is preferred over the plants in these other locations. And we just calculated the hypothetical value of pi AB. We can compute the next row of pi values by comparing the plant in Belgium against the other plant locations. And the same is true for the remaining plants. Phi plus and phi minus are defined as the positive and negative outranking flows, which for the power plant in Italy would be the sum of the first row and the sum of the first column, respectively. The net outranking flow for a given alternative equals the positive outranking flow for that alternative minus the negative outranking flow for that alternative. To rank alternatives, Promethay 1 uses the positive and negative outranking flows for each alternative, and Promethay 2 uses the net outranking flows for each alternative. Returning to the fuzzy preference relationships, we've already seen the linear preference relationship. However, there are others, such as the insensitive relationship, the indifference relationship, the step relationship, the linear with indifference relationship, and the Gaussian relationship. We will label these 6 types of preference relationships types 1 through type 6. Next, we'll assign each criterion with a preference relationship type. Depending on this type, certain parameters, P, Q, and sigma, are also needed to define the relationship. For example, the criterion for the number of workers follows a type 2 indifference relationship. Since the units for this criterion is the number of workers needed to run the plant, Q equals 10 means plant A needs to require at least 10 fewer workers than plant B for there to be 100% degree of truth to the proposition that a plant in country A is preferred to a plant in country B for this criterion. Otherwise, the degree of truth for the proposition is 0%. Power production follows the type 3 linear preference relationship with P value equal to 30. Since the units of power are in megawatts, P equals 30 means a plant in country A needs to produce at least 30 megawatts more power than a plant in country B for there to be a 100% degree of truth to the proposition that a plant in country A is preferred to a plant in country B for this criterion. If a plant in country A produces less than a plant in country B, there is no preference. And if a plant in country A produces between 0 and 30 megawatts more power than a plant in country B, the degree of truth for the preference is linear between 0% and 100%. The linear with indifference relationship used for construction costs has thresholds of $50 million and $500 million. And the step preference relationship used for annual maintenance costs has thresholds at $10 million per year and $60 million per year. The insensitive preference used for the environmental impact criterion does not require any parameters. And the Gaussian preference used for security follows the equation 1 minus e raised to the negative 1 times the deviation squared divided by 2 times sigma squared. If we were to calculate the actual value for pi AB, we would begin by quickly scanning the values in the table with regard for the objective for each criterion. If the values associated with the power plant being in Italy is less desirable than the value associated with the power plant being in Belgium, as it is for the number of workers, construction costs, and environmental impact, we automatically know there will be no preference for these criteria. Next, we'll more closely analyze the other three criteria. Since a power plant in Italy would produce 90 megawatts and a power plant in Belgium would produce 58 megawatts, the deviation is greater than the threshold value of P equals 30 megawatts. Therefore, the preference is 100% true for this criterion. The maintenance cost follows a step preference relationship with thresholds at $10 million per year and $60 million per year. Since the deviation is $43 million per year, the degree of truth a plant in Italy is preferred over a plant in Belgium is 50% true for this criterion. Lastly, the Gaussian preference relationship is evaluated by plugging in 4 for the deviation and 5 for sigma, and h of d sub 6 equals 0.274. Returning to our equation for pi AB, the weights are multiplied by the preference relationship values, and the pi AB value equals 0.352. The value of 0.352 is inserted in for pi AB. After comparing a power plant in Italy against a power plant in the other countries, the pi A values are calculated as shown. In the same way, the remaining pi values are also calculated. As previously described, the positive and negative outranking flows are determined by summing the first row and first column, the second row and second column, the third row and third column, and so on and so forth. The positive, negative, and net outranking flows are tabulated. If we first consider Promethay 1, we're only interested in the positive and negative outranking flows. In Promethay 1, the relationship between two alternatives can be classified as a preference, an indifference, or as incomparable. Before these relationships can be defined, we first need to look at the partial relationships. Given two alternatives, A and B, alternative A would be strongly preferred over alternative B if alternative A has a higher positive outranking flow. Alternative A would have a weak preference over alternative B if alternative A has a smaller negative outranking flow. And the two alternatives would be indifferent if their outranking flows are nearly the same. The relationships between alternatives A and B are based on the partial relationships. If we assume an indifference threshold of 0.1 and compare Italy to Belgium, we notice that a power plant in Belgium is preferred over a power plant in Italy because Belgium has a higher positive outranking flow and the negative outranking flows between the two countries are indifferent. If we compare Belgium and France, this would be an example of incomparable alternatives. An example of indifferent alternatives would be between Italy and Germany, whose positive and negative outranking flows are both less than 0.1 from each other. When one alternative is preferred over another, as Belgium is over Italy, an arrow is drawn from the non-dominated alternative to the dominated alternative. After all 15 pairs of power plant countries are compared this way, the preference relationships are shown using a network of arrows. Since Prométhée assumes transitivity, certain arrows can be removed without changing any relationships. Since Portugal is the only non-dominated alternative, it is the best country in which to build a power plant, using Prométhée 1. Prométhée 2 only uses the net outranking flow to determine the best alternative. In Prométhée 2, an alternative A is preferred over alternative B if its net outranking flow is higher. And the two alternatives are indifferent if their net outranking flows are nearly the same. Drawing out the relationships, like before, we notice that, once again, Portugal is the optimal solution. When reviewing the possible solutions, the answer is E.